right, here we go. Thursday, May 14th's problem. We're going to be looking at blocking, why we need to randomize, and replication. Researchers are designing an experiment to compare two different types of running shoes, A and B, to investigate which type is better for minimizing running time for a 1-mile run. Interesting. So I wonder if you can really make faster shoes. The experiment will consist of distributing the shoes to runners who are classified as either professional or recreational. A randomized block design is planned, with blocking by classification of runner. Right, so that's a nice form of control for lurking variables, right? You might have faster runners versus slower runners, and you want to try and alleviate any confounding or lurking issues in the background. Random samples of 50 professional runners and 50 recreational runners will be selected. Each runner within each classification, right, that's the block, will be randomly assigned to wear either type A or type B shoe, and their running times will be recorded for a 1-mile run. What is a statistical advantage to blocking? All right, I ran out of room on this one. They're looking for two things. All right, so they're looking for you to talk about control and decreasing the variability. Right? So control and decreasing the variability, because if you had all the runners in one big pot, you're going to have times really spread out. But if you can isolate each type of runner, then you might have a more closer together data set, right? Less variability. More close together data set. There you go, grammar. All right. Blocking is used to control for a source of variation in the response variable from treatments. In this situation, the response variable is the running time. Professional runners are likely to have faster, or you might say lower, run times than the recreational runners. So the variability should be smaller within each block group than when combined. Having less variability, here's why it's important. Having less variability makes it easier to detect a significant difference between the types of shoes. All right, so if you've got less variability, it's easier when you get your little magnifying glass and you're looking at the tails, it's easier to find those significant p-values. All right, so blocking is a form of control. It's going to make your variability smaller within each group. Having less variability makes it easier to detect significance. All right, problem B, boy. Why is it important to randomize the type of shoe the runner will wear instead of allowing the runner to choose the shoe? Well, if you're a professional runner, you might already know which shoe is the best. So we need to control that. Randomizing treatments is used to reduce the possibility of confounding variables, right? Explanatory is that shoe type, and response is your run time. So we're trying to make sure we don't confound which one is influencing it. Self-selection instead of randomized shoe types could introduce a confounding variable. Perhaps professional runners have a strong preference and all self-select the same shoe type. Confounding the results. Is it the shoe or is it the professional level that resulted in the fast times? Again, if you let runners choose, the professionals might all gravitate towards the same shoe and it's going to mess up your results. So we're looking for two things here. They want you to define your variables, and then they want you to talk about some type of result. I went with the professional runners all gravitating towards the same shoe, but maybe you have something else if you thought outside the box. I don't know. So two things. All right, and then part C, explain how the design of the experiment will address replication. What is the benefit of replication? Be careful. Replication does not mean you can redo the experiment on Tuesday. All right, replication means you've got enough people, right? You've got enough subjects so that you can start to see a pattern in your results. Okay, so two things here. They're looking for you to answer the how, and then the second question was the benefit. All right, so answer the how and then the benefit. Okay, so how? The design addresses replication by assigning 50 subjects to each shoe type. You did not have to show this diagram. That was my brain just trying to organize what this problem was all about. All they're looking for you to do was address that we have 50, right? You have enough subjects that you can start to see a pattern. The benefit Replication is important in order to estimate the natural variability in running times within each type of runner and shoe type. Then you can compare times to better see significance from your treatment. That says treatment, sorry. In other words, it helps to show if times are just due to chance or not. I spelled that wrong. Due, D-U-E. All right, it's just due to chance. Okay, so address the how, right? We had 50, which is what replication means. You have a lot of subjects, and the benefit is so that you can get a better idea of the pattern. All right, on to the next one.